On this page, we have several exercises that you can try on your own with this idea of substitution. If you want, go ahead and pause the video now and try and work them out based on the example on the previous page. If you want to watch another few examples, I'm going to start working them out now. For the first exercise, we need to substitute x equals 3 into f of x. We're given f of x as x squared plus 2x. That is my rule. And so, with substitution, wherever there was an x in the rule, I will replace with parentheses and that substitution value, that input, that domain value, and then leave everything else as it was. 3 squared is 9. 2 times 3 is 6. So my answer is 15. My input, or my independent variable, was 3, and my output, or my range value, is now 15. This next one might be a little more interesting. We have a letter and a number in it, f of 2a, so we're going to replace any x's with 2a. Being careful to put parentheses around what I am substituting. 2a squared, we can distribute that square in because the 2 and the a are multiplied together. So we will have 2 squared times a squared, or just 4a squared, plus 4a. This simplifies to 4a squared plus 4a. Notice that these two terms do not match because the degrees are different. So we cannot combine this any further. The exponent on the first term is 2, and the exponent on the second term is 1, and so we've gone as far as we can with this statement. Now for example E, we have 3 times the function f of 2a. Well, we already know what f of 2a is, so we can just write it as 3 times what we got in part C. So I'm just going to replace f of 2a with that expression I have here, 4a squared plus 4a. And you could simplify this if you wanted. We could distribute the 3 through, and we would have 12a squared plus 12a. For the next one, we have f of negative 2. So f of negative 2 equals negative 2 in parentheses squared plus 2 times negative 2 in parentheses. This will give me a negative 2 times a negative 2, which will be a positive 4. A positive 2 times a negative 2 will be a negative 4. And so my total answer when simplified is 0. And then finally for part D, we have f of 2a plus 5. Now remember, I already know what f of 2a is, and so I can simply tack plus 5 at the end of my calculation. So I have 4a squared plus 4a, and then I'll just bring that plus 5 down as a separate portion, a separate term of my function. Since none of these terms are like terms, their letters and numbers do not match. So the letters a and the exponents 2, 1, and a to the 0, basically. Anything to the 0 power is 1. So since none of those are like terms, we can just stop there. Go ahead and give example 4 or exercise 4 a try. This one is called a rational function because it has in the numerator more than one term and more than one term in the denominator. the rules still apply. We'll have s of negative 2 means we will substitute negative 2 into our function. Wherever there was an x, we'll replace it with a negative 2. So 3 times negative 2 minus 4 all over 2 times negative 2 plus 5. That is our new statement with the substitution included. Now on the next line, we will calculate these numerator statements and denominator statements separately and then simplify. So we have 3 times negative 2, which is negative 6, minus 4, that's the numerator, and 2 times negative 2 plus 5. So that would be negative 4 plus 5 in the denominator. This will give me negative 10 in the numerator and 1 in the denominator. So my answer is negative 10. For part B, I have s of 1/2. So instead of x, I will replace x with 1/2. This will give me 3 times 1/2 minus 4 over 2 times 1/2 plus 5. In the numerator, 3 times 1/2 will cut 3 in half. So I'll have 1.5, or I could say 1.5 minus 4 all over 2 times 1/2 will just give me 1, because half of 2 is 1, plus 5. This will give me a 1.5 minus 4. Now you can do this in your calculator. You could do this a lot of different ways. 1.5 minus 4 equals negative 2.5. So we'll write the numerator as negative 2.5. And in the denominator, 1 plus 5 is 6. Now the question is, will this reduce? You can check this by taking the numerator, negative 2.5, and dividing it by 6. And click enter. Now notice we have this repeating decimal. It doesn't look too nice. It's negative 0.41666666 repeating, and then at the very end it's rounded up to a 7. If you click math and then enter, which will give you math frac, short for fraction, and then hit enter again, it will calculate the reduced fraction form of that decimal. Now, in most cases, your homework platform, when it asks for an exact fraction or an exact answer, it doesn't want this repeating decimal up here. It wants this reduced fraction. So our answer is negative 5 over 12, or negative 5 divided by 12, with the negative out front. Let's take a look at C. We have s of x plus 3. So wherever there's an x, we'll now write x plus 3. In the numerator, we'll have 3 times x plus 3 minus 4 all over 2 times x plus 3 plus 5. Now notice my x plus 3 is in parentheses, just like all my other ones. You might find it helpful to color code your substitutions. X plus 3 is your input. It's your independent variable. It's your domain. And the output is what you get when you simplify this statement. So let's go ahead and distribute the 3 through to x and plus 3. That will give me 3x plus 9 minus 4. That's the numerator. And in the denominator, 2 times x and 2 times 3. So that will give me 2x plus 6, and then plus 5. That was just left over. So now if I simplify this, I'm going to have 3x plus 5 all over 2x plus 11. Since the numerator and the denominator are like simplified expressions, You might be wanting to do something interesting, let's say illegal math, where you divide out your x's and then you get 3 plus 5 over 2 plus 11. You can't do that because remember, this is a division. So if you wanted to do division with this statement, you would have to use polynomial long division, where the numerator is your dividend and the denominator is your divisor. And it would look something like this. And we're not working on that right now. So this is as far as you can go. So write a little note, stop here.